to this video. In this video, we are going to understand spanning tree. Now, before spanning tree, in your institution, you are going to find switches distributed across your infrastructure and in separate locations. Now, these switches might be interconnected to provide redundancy. In case a link goes down, interconnecting these switches will provide a different link to another switch or to a root bridge. So without wasting much time, I have 5 switches here. I'm going to start all of them, and we are going to identify the root bridge of the topology. So I will start with switch 5, web console, and then I'll also open switch 3. Okay, so on switch 5, I'll do show spanning tree, and currently switch 5 is in the root of the topology, and it has a cost of 300 to travel to the root bridge, and I'll explain it. And also it has interface 00 configured to be a root port. Now the cost is a distance between 2 switches, and currently I'm using a Cisco IOU layer 2 switch, and it runs at a speed of 10 megabytes per second. And with respect to the IEEE standards, when a switch is running at 10 megabytes per second, it has a cost of 100. When it's on gigabyte, it has a cost of 4, and when it's on 100 megabytes per second, it has a cost of 19. So at the moment, I have my switch running at a speed of 10 megabytes per second. So therefore, the cost between 2 switches is 100. So currently, switch 5 has a cost of 300 traveling to the root bridge, and as we can see here, it's not the root bridge. So I will check on switch 3, and I'll do show spanning tree, and then switch 3 also happens not to be the root of the topology because it has a cost of 100 traveling to the root bridge, and then also it has a root port. Now a root port is a port through which a bridge can connect to the root bridge, and we have interface 01 being an alternate port because it's being connected to another switch, and therefore it is receiving BPDUs from that switch. And if we check on switch 3, interface 01 is directly connected to switch 2 over here. So we couldn't find the root bridge on switch 5 and switch 3. Let's check on switch 1 to see. So switch 1, web console, show spanning tree, and therefore switch 1 is the root of the topology, and therefore is the root bridge because the priority ID 32769 corresponds to the bridge ID 32769. Unlike switch 3, it has a root priority of 32769, which happens to be that of switch 1. So going back to the topology, let's notice the root port over here, and then the cost. I'm going to explain it. So now, for example, on switch 5, traffic has to travel throughout the topology to the root bridge. So therefore, a root port is a port assigned to a switch for traffic to travel through to the root bridge, and therefore switch 4 is not a root bridge, neither switch 3 or switch 2. And we also said the cost of data traveling between 2 switches is 100 because my switches are running at 10 megabytes per second, and then if I was using 1 gigabyte per second, the cost was going to be 4. So from switch 5, data has to travel to switch 4 at a cost of 100, and traffic is designated to go to switch 1. So therefore it has to travel from switch 5 to switch 4 at a cost of 100, and therefore from switch 4 to switch 3 at a cost of 100, and then on switch 3 it has to pass through the root port, and the root port is the port assigned to a switch to get to the root bridge. So we have 100 cost over here, we also have 100 cost over here, and therefore from switch 3 to switch 1 also comes at a cost of 100, and therefore if we check on switch 5, we are going to see 300 cost to travel for data to travel from switch 5 to switch 1. Now on switch 3, we have a cost of 100 over here, and then ET00 has been assigned as the root port, and then ET01 has been assigned as the alternate port. Now this is ET0, which has been assigned as the root port, because root port is chosen based on the lowest path cost to the root bridge. So looking at switch 3, it has 3 interfaces: ET0, ET01, ET02, and it wants to get to the root bridge, so therefore it has to choose the lowest path cost to the root bridge, and therefore that path cost happens to be on ET00, and therefore it comes at the cost of 100. So there is no need to for data to travel on ET01 to switch 2 at a cost of 200 before it gets to the switch 1, whilst we have a very short path here which comes at the cost of 100. So on switch 3, we have a cost of 100 getting to the root bridge. So what if we shut this interface down? We are going to force traffic to pass from we are going to shut this interface down, and then for traffic to get to the root bridge, it has to pass through switch 2 before it gets to switch 1. Now, so let's go on switch 3, and I will do config t interface e/00 shut. So notice here at the moment our Ethernet 00 is the root bridge, and it has a cost of 100 traveling to the root bridge, and as you can see here, the cost is 100. So I'm going to shut the interface and do show spanning tree, and now you can see the cost is 200, and then interface 01 has been configured as the root port. First, the root port was on interface 00, and currently it's on 001 because this interface over here has been blocked, so traffic has to go through ET01 to switch 2 to switch 1. Now let's go back to switch 5. So switch 5 is trying to send traffic from here to switch to the root bridge, so traffic has to go through switch 4 to switch 3 to switch 2 and then switch 1 before it gets to the root bridge. So let me go to switch 5 and do show spanning tree, and as you can see, it has a cost of 400 because traffic is sent from switch 1 to switch 4 at a cost of 100, from switch 4 to switch 3 at a cost of 100, making 200, from switch 3 to switch 2 at a cost of 100, making 300, before switch 2 to switch 1 at a cost of 100, making 400. So that's how data is packets are forwarded from switch 5 to switch 1 over here. Now that's the beauty of spanning tree, as I said earlier. So should in case this link goes down, traffic will be forced to switch 2 before getting to switch 1. Now if I bring the interface back up and running, we should have interface no shut. So the interface is up, and then so currently traffic is forwarded through Ethernet 01 to switch 2 at a cost of 200, and therefore we said root ports are assigned based on the lowest path cost to the root bridge. So on switch 3, I'll do show spanning tree, and as you can see, interface 00 has now been configured as the root port at the lowest cost to the root bridge over here. So that's the beauty of spanning tree. So thanks for watching this video, and see you in my next video.